Hello and welcome back. So we have done the ANOVA test, the hypothesis testing on designation and the salary, and decided to go with one hot encoding. And we understood what is one hot encoding and why we do one hot encoding. To avoid, right, while doing one hot encoding, we use dummy variable. The drop first is equal to true to avoid dummy variable trap. Now we have taken the gender example. If you create two columns for male and female, they are going to be negatively correlated strongly. To avoid that, if you create only male column or female column, if you say 0, that means male. If you say 1, that means female, right? If you take female column, right? So we can do that way. So here also we have 7 columns, and we have created only 7 categories, and we have created only 6 columns. If all are 0, that means the 7th column, the 7th category is the one which is the record belongs to. Okay. So let us try to do the same kind of test on gender and salary, right? Gender and salary. So when I did the what you call it as bar graph, I've got that there is not significant difference between the salaries. Whether the gender is not deciding the salary. That's a fact actually. Depending on talent, the salary should be given, not by the gender, right? So it looks like decent, but let us try to see any outliers are there with box plot. It shows some, but we will not care. Just to do a graph, we have done it. And there are only 2 pairs here, right? Male and female. We can use the OLS algorithm to calculate the p-value. So I have calculated the p-value, and the p-value is actually the F statistic value, and the F statistic p-value is, this is what we need to see for the ANOVA, right? So this value we need to see. This is actually 5 zeros and 115, right? 5 zeros and 115. I have got something else here. Let me change it. 5 zeros and 115, which is actually definitely less than 0.05, right? Then that means we can reject the null hypothesis. We can go with the label encoding. When you reject the null hypothesis, that means there is strong relationship between the gender and the salary. The test is giving us that there is strong relationship with gender and salary. But this is a safe thing here. Even if you do dummy variables, right, or one hot encoding, you will be creating only one column and giving zeros and ones. Here also it's going to do the same thing. It will assign to male 0 and female 1, or to female 1 and male 0. That's it, is one and the same, right? We just did it to show you when there are only 2 columns how to do it. Okay. So let us try to do with qualification and salary also. Let us try to look at the bar graph. It seems like 3 categories are these 2 categories, right? The graduation and post graduation are not deciding the salary, but PhD and postdoc are actually deciding the salary. So it means some pairs have got strong relationship with salary, or they have strong hold on deciding the salary, and some pairs they don't have. Most probably we will go with one hot encoding. Let us try to look at the box plot also, and then let us try to do the pairwise ANOVA test with the multi comparison. Okay, so you can see this, right? Between grad and PhD, you cannot reject. Okay, and between grad and post grad, you cannot reject. That means reject null hypothesis. That means you reject null hypothesis is false. That means you have to accept null hypothesis, right? So there are only 3 pairs which are giving true, and 3 pairs which are giving false. That means it's kind of here and there, right? There is strong relationship or strong hold for some categories or some graduations to decide the salary from some qualifications, and some not. So in this case, we will go with one hot encoding. If there is clear picture, all are saying true here, then we will go with label encoding. So we have went to one hot encoding. If you see this here, there are 4 categories in this particular column, right? The qualification column. But here we have got only 3 columns here, and this particular record, the index 71 record, belongs to postgrad, or in that particular column, the qualification of the person is postgrad. Right? Rest all are having zeros. That means those records belong to grad. Right? Postgrad, PhD, and postdoc are there. Grad is not there. That means the 321, 1254, these records belong to graduation. Or in that column, in that row, we have grad as the value. So we did one hot encoding because some columns, some features have got strong hold on the salary, deciding salary, and some not. Okay. If everybody has got, every category has got strong hold in deciding the salary, we'll go with label encoding. Let us try to see the next one, degree and salary. Always the null hypothesis is independent, no relationship. The alternate hypothesis is dependent, right? So let us try to do the test. Right, I did not do the the bar graphs here. When you look at the pairwise things, right, only three pairs have got true and rest are all false. Basically, when there is 50-50 chance, right, one hot encoding works best. But if most of them are false, right, even if you remove the column, that's okay. But we don't want to remove the column, or maybe it is better we remove the column. We removed the column, okay, because most of them are saying false. That means it is kind of zero variance column. Most of the pairs have got no hold on deciding the salary, so we are dropping the column, okay. And the next thing is educational institution and salary, right? Let us do an ANOVA test. The bar chart I have given, then histogram, and then ANOVA test. It is also here and there, right? 50% of the pairs have got hold, 50% did not have hold on deciding salary. So we'll go with one hot encoding. So when we did this one hot encoding, right? If you look at this test set is equal to pd.getDummies and passing train set and the columns, right? Which columns you need to do one hot encoding. Here we are passing only one column and prefixed with the column name and drop first is equal to true. What happened is it automatically removed the educational institution and added these columns. Okay. If you do scikit-learn way, it will actually give you a numpy array, right? It will give you a scipy array and you need to convert it to numpy array, and then you need to create, you need to convert your data set into numpy array and then merge it. But using the pandas data frames, right, it is easy. If you run this one statement, right, it will actually remove the original column and add the one hot encoded columns. Before we do this one hot encoding statement, right, we should make sure that to convert the column to categorical and pass the allowed values there, right? This dictionary has got all the allowed values, right, so that it will create appropriate number of columns, okay. So if you experiment with this code, you will understand what I am actually trying to explain. Employee band is another categorical column, and let us try to see what happens there. It looks like there is significant difference, and right, there is, right, every column, every pair is saying true. That means employee band is deciding the salary, or there is a significant difference between each pair's means and the standard deviations, okay. So now we can go with the label encoding. If everything is true, I said we can go with label encoding. We went with label encoding. Now if you look at the test set size, the columns got increased. Now we will split the data into train X and train Y and use the X and Y data sets in building our model. Let us meet in another session to see how to build a model using grid set, CV and pipeline. Thank you.